Hi there, Mr. Holcomb here with another episode of The Math Behind the Module. This is Lesson 1, Module 5. Alright, we're moving right along. We're into Module 5. So, the area of parallelograms through rectangle facts. So, the opening exercise says to name each shape. Okay, so if I look at this, I'm going to say, okay, well, that is a triangle. All right, that is true, but let's be more precise. How about a right triangle? So since I have a right angle here in this corner telling me that that is 90 degrees, then this is a right triangle. Now in class, students thought that this was a rhombus. Some students, not all. But a rhombus is a four-sided figure where opposite sides are congruent and all sides are congruent. Actually, it's like a square pushed over so that the 90-degree angle at this base got smaller and is acute, and the top one got larger than 90, so it is obtuse, and opposite angles are congruent. But this is not a square, this is a rectangle pushed over. And when we push a rectangle over, it is not a rhombus, it is just simply a parallelogram. Acting goofy, I can't spell. Parallelogram. All right. This is a triangle. Okay. Now, in class, we might have said that these angles all look the same, so that'd be, or all sides look the same, that'd be an equilateral triangle or equiangular triangle if you're in geometry, then we're not there yet. But we can't assume sides are congruent unless something tells us that they are, or the angles. So we do know that these are all less than 90 degrees. So let's just call it an acute triangle. And this is a 90, I'm assuming that's a 90-degree angle. So if that is a 90-degree angle, and that is a 90-degree angle, so I'm really not happy with this diagram because they do want us to identify this as a rectangle. So opposite sides are congruent and parallel, and all four angles are congruent and are 90 degrees. That is a rectangle. Now this one has two sides that are parallel. The symbol for parallel are little arrows, so that is parallel to that, but this is not parallel to this. If we can drew these continuously, they would meet up top. So parallel lines never cross, so that is not a parallelogram, but it is a parallelogram. It is a quadrilateral, a four-sided figure whose opposite sides are parallel, and that is called a trapezoid. Okay, so there's the 5 terms that we have. There's the 5 shapes that we're going to be working with, and as we said, we're doing areas of parallelograms. So what I'm going to do here to explain this, it says find the area of each parallelogram below. Note that the figures are not drawn to scale. Now, this is 6, and this is 5, so it is not a rhombus because the sides are not congruent. It is a parallelogram. But there's an interesting feature about parallelograms and their areas. If I were to draw very carefully here, I'm just outlining this triangle right here, and then I change colors and I outline the trapezoid that is here. Okay? And then if I choose to move these over so we can get a better look at these, because that wasn't a very good drawing, but that is the shape that this is. Okay, these are the same. Now if I take this and slide it over here, okay, then we have a vertical line here and a vertical line here that's congruent, a horizontal line here and a horizontal line here that's congruent. And that, in fact, is a rectangle. Okay, so there's our rectangle right there. So the area of a parallelogram is the same formula as the area of a rectangle. So in order to do these, now that I've shown you visually, we're now going to assume that we now realize that this is a parallelogram, and the area of a parallelogram equals base times height. You can also use length times width, but I'm going to be more comfortable using base times height. The base is what is horizontal down here, and that is 6 centimeters. So in order to solve these algebraically, and I really stress this in my classroom, is step 1, write the formula, which is done. Step 2, substitute in givens into the formula. So the base is 6 centimeters, and I'm going to write the unit of measure with it. I'm not just going to say 6. The base is 6 centimeters times the height. This is not the height. Height is the distance from here to here, and the distance from something up here to the base down here is a vertical line. So this is my height, not the 5. 5 is my diagonal here. The height is actually 4 centimeters. Okay, so step 1, write the formula. Step 2, substitute in the givens. Step 3 is simplify and solve. 6 times 4 is 24. And I explained to my class that 1 times 1, which is 1 squared, equals 1. 2 squared equals 2 times 2, which equals 4. And 3 squared equals 3 times 3, which equals 9. And so on and so on and so on. Just, I was solidifying the fact that when you multiply something times itself, it's the same as being squared. 2 times 2 is the same as 2 squared. 3 times 3 is the same as 3 squared. So the reason I'm doing this is centimeters times centimeter equals centimeter squared. So the answer to this is the area equals, the area equals 24 centimeters squared. Or you could say 24 square centimeters. Okay, so hopefully you get into the habit of doing this as well. Step 1, write the formula. This is also a parallelogram. So if I move this triangle over to here, it would be here, and it would not be here, so therefore it would form this rectangle. Okay, so area equals base times height. Write the formula, step 1. Step 2, substitute in the givens. The base is 25 meters times the height, which is 8 meters. So the area equals 25 times 8, which is 200, and meters times meters is meters squared. So there is the area of this parallelogram. Okay, number 3, or part C. Step 1, write the formula. A equals base times height. This is a parallelogram. I look at the 12, I look at the 11.5, it is not the same distance, so I can't call it a rhombus. It is a parallelogram. Substitute in the givens. A equals, my base is down here, 12 feet. My height is this vertical distance of 7 feet. So then I simplify and solve. 12 times 7 is 84. Feet times feet, or anything times itself, is feet squared. So the area of this parallelogram is 84 feet squared, or 84 square feet, either way you want to say it. Okay, now step 2 says draw and label the heights of each parallelogram. Use the correct mathematical tool to measure in inches the base and height, and calculate the area of each parallelogram. Okay, so in this section it says to draw and label the height of each parallelogram. Use the correct mathematical tool to measure in inches the base and height, and calculate the area of each parallelogram. Now I just want to inform you that my measurements may not be exactly the same as your measurements from the module, and because on screen it may be, the size may have been manipulated a little bit and changed. But if I look at this, again it said in inches, so I'm using the inches side, not the millimeters or centimeters. So from here, there's my 0 over to 2. So I would say that this base is 2 inches. Okay, now if I rotate this till it says 90 degrees, and then move it so that I'm going to put it right on this corner here, and I'm going to draw height as a dashed line. Okay, so there's my height. That forms a right angle here. So our height, I would just want to stress that the height is perpendicular to the base, which means that it makes a 90-degree angle. Perpendicular means 90-degree angle. An intersection at 90 degrees. Okay, so now when I measure that, now here's where mine might be different. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 sixteenths. I'm going to use the exact value, and I'm going to call that 9 sixteenths of an inch. Yours will probably be different from your paper. I encourage you to use a ruler and measure it and use the values you get, but I'm just showing the procedure. So now to solve this, I would say area equals base times height. Write the formula. Step 2, substitute the givens. Area equals 2 inches times, okay, here's where I'll use parentheses, I guess. 2 inches times 9 sixteenths of an inch. Oops. 9 sixteenths inches. Okay, base times height, and now I simplify. And 2 times 9 is 18 over 16 inches. So my area is 1 2/16, or 1 1/8 inches. Okay. I highly encourage you to leave it as a fraction and get used to working with fractions. Think of 2 as 2 over 1. So 2 times 9 is 18, and 1 times 16 is 16. 16 will go into 18 once with a remainder of 2, and 2/16 reduces to 1/8. That's how I got my answer. And it was inches times inches, so I should say inches squared. So my answer is 1 1/8 square inches. Okay, that is the area of that parallelogram. Okay, so let's try this again. Since my ruler is already vertical, I will line it up here and draw a dashed line for my height. Okay, and that is a right angle, just to remind you that that's what heights are. It's perpendicular to the base. They form a 90-degree angle. And now I'm going to move my ruler so that my 0 is right on the side line, right here. And that is 1 1/2 is here. And these are 16, so there's 9, 10, 11, about 1 11 sixteenths. 1 11 sixteenths inches. I'm going to rotate 90 degrees till it says 0 degrees right here. I'm going to move this over to 0, and it looks like it is 1 1/2, which is 8 sixteenths, 9 sixteenths, 10 sixteenths, which is 1 5/8. So the base is 1 5/8 inches. Okay, move that down for the next problem. Area equals base times height. Write your formula. Substitute in your givens. The base was, now I'm going to make this mixed. 8 times 1 is 8, plus 5 is 13 over 8 inches. And I'm going to multiply that by 1 11 sixteenths. That would be 16 times 1, which is 16, plus 11 is 27 sixteenths inches. And I multiply those. 13 times 27. Okay, so here's my calculator. 13 times 27 equals 351. So that's 351 divided by 16 times 8, which is 128. Okay, bring back my calculator, and 351 divided by 128 equals 2.74. This calculator is going to, it does not reduce. So it's 2. So the area equals 2. And my remainder is 128 times 2 is 256. So 351 minus 256 is 95. So it's 95 over 128. So I'm just going to check one more time to see if 95 divided by 128 will reduce. And it does not. Okay, so that was a really odd value simply because of my ruler and my scale. Yours probably come out better than this, but I need to remember that that is inches times inches or inches squared. So it's 2 and 95 1/28 inches squared. Okay. Again, it's not the value we get, it's the procedure. Okay, now this is a rectangle pushed way over, so this is a parallelogram. This base is parallel to the top, and this left side is parallel to the right side. So what I need to do in this problem is line up my ruler here with the base and extend my base out like so, rotate 180 degrees, or 90 degrees I mean, so it says 90 here. Bring my ruler over here and draw a perpendicular line down to my base, showing that it is 90 degrees. So there is my height right here. So I'm going to measure it since my ruler's already rotated 90. So if I measure from there to there, it's 1 and 1/2/3/16. So this is 1 3/16. Try to write that legibly. 1 3/16 inches. That's the height. Okay, now I'm going to rotate this down to 0 degrees. Move this over. Now when we measure the base, we're only going to measure the original base, which goes from here to here. So it's right about there. So that is 1, and I would say 2/16 roughly. So let's call that 1 1/8. So the base is 1 1/8 inches. To solve this, we say area equals base times height. Substitute in our givens. 1 1/8 is 8 times 1, which is 9, plus 1 is 10 over 8. So that's 10 over 8 inches. We're going to multiply that by 16 times 1 is 16, plus 3 is 19 over 16. Make those fractions improper, and then do the math. 10 times 19 is 190. 8 times 16 is 128, just like the last problem. Okay, so we have 190 over 128. So the area equals, well, 128 times 2 is 250 something, so it won't go twice, but it does go once. And 190 minus 128 is 62 over 128. Okay, so I'm going to reduce that. I'm going to show you that that's what that turns out to be. So 190 divided by 128 is 1.48375. And if I change that to a fraction, it is 95/64. Okay, or 95 minus 64 is my remainder, 31, over 64. So the area is 1 31 over 64. 31 is prime, so I can't reduce it any further. And inches times inches is inches squared, and inches squared. So the area is 1 31/64 inches squared. Now 32/64 is a half, so it's really close to 1.5 square inches. Okay. Scale threw off my values. They're not as nice as the ones that you probably have on your paper. But you get the idea, I hope, from the procedure. Okay, so number 3 says, if the area of a parallelogram is 35 over 42 centimeters squared, and the height is 1/7 centimeter, write an equation that relates the height, base, and area of the parallelogram and solve it. So here's where the formulas come in really handy. So we are going to use this formula here. It's the area equals base times height. A lot of students have trouble with these types of problems because we know a total and we know one of the pieces, but we're missing the other piece instead of knowing 2 pieces and finding the total. But it's the same thing. We have 3 variables. We plug in our givens. The area is, that's my A in this case. So that is going to be 35 over 42 centimeters squared equals, that's my A, My b, I don't know, times the height, which is 1 over 7 centimeters. Okay, so now we have an unknown and we're multiplying by a fraction. And in order to move this 1/7 to the other side of the equal sign, we multiply by the reciprocal. So I'm going to multiply by 7 over 1. Okay. Or in other words, let me show this before I do that. You're going to wonder what happened to the centimeters. So to get rid of this, I need to divide by 1 over 7 centimeters. Okay, but dividing by 1/7, remember, is the same as multiplying by 7 over 1. So you flip the fraction and you switch the sign to multiplication. Okay, we've done this many times now. So I'm going to, this is the same as multiplying by 7 over 1. So I'm going to ignore this and change that to multiplying by 7 over 1. But I'm still going to divide by the unit measurement because centimeters divided by centimeters is going to cancel. So I'm going to multiply this by 7 over 1. But the centimeters is going to go in the denominator like it is down here. It's going to stay, or actually I could write it like this, leave the centimeters in the denominator. Okay, so when I do that, I'm going to reduce. 7 will go into 42 6 times. And the centimeter will cancel the centimeter because centimeters squared divided by centimeters. So this is what's happening off to the side with our unit. We have centimeters squared divided by centimeters. And centimeters squared is the same as saying centimeters times centimeters. When I divide by centimeters, one of them cancels, leaving me with 1 centimeter by itself. So I now have 35 over 6 centimeters equals my base. And 35 over 6 is 6 times 5 is 30. With a remainder of 5 centimeters. So my base is 30 and 5/6 centimeters. Okay, that is the end of lesson 1. Go do your problem set.